Hey everybody, this is Larry. This is me going over Q4 of the recent Leetcode daily Leetcode contest, car fleet 2. So basically you're given these positions, and there are a couple of ways to do it, and I think there are some mathematical ways of doing this with respect to convex hull and the lower hull and stuff like that. But actually that's not how I did it. I actually, and you could watch me solve this live during the contest afterwards. So be sure to hit the like button, the subscribe button, join me in Discord. But did I say that already? But yeah, so you can actually solve this with monostack, and that's how I did it. And the thing that I always say about monostack, and I hate actually spoiling that a little bit, because for me, I never think about a monostack. I think about the questions that I ask to solve this problem. And for me, just visualizing this, I go, okay, there's a couple of examples, but for example, 3, 4, and 5, 4, right? Well, they'll never catch each other, but we know that, for 3, 4, it catches up to 6, 3, right? Because, well, 4 is bigger than 3, so you know that at some point it would catch up to that. And then from that alone, you ask yourself, okay, so what is the next number to the right of this number? So, given this car, what is the next car to the right of this car that has a slower speed? Because then you know that you're going to hit it. So that's part one. And that's not enough, but that's basically the questions that you ask. And it turns out that we use a stack, and keeping that as an invariant of the largest number to the right, that is, in a monotonically increasing way. And the variant is such that, if you have a 4, okay, well, this one is a bad example, but let's go back to here for a second. You push the speed of 2 on the stack, you push the 3 on the stack. Let's actually do that in a live way. Give me a second. So you have something like this. You know that 3 is going to be faster than 2, so that's great. Here's the 1, right? Well, the 1, let's think about what this means to update, right? Because here 2 means that 2 is the smallest number to the right of everything to the left, because that's just by default, there's only 1. 3 in this case, well, there are only 2 questions, right? So now let's say your stack is 2 and 3, and now okay, let's change the stack a little bit. Let's change this to 5. Sorry, I'm jumping a little bit. Let's say we have a number 3, right? So this is the stack. Let's say a number 3 comes in, right? Well, then the question is, what's the smallest number? Well, let's think about putting this on a 3 for now, right? Where do we want to put the 3? And then that means that, okay, later on, let's say there's a 4. Well, what is the next number that is smaller than a 4? Well, it's always going to be 3, of course. And it will never be 5, right? Why would it never be 5? Because anything that's after 3, if it's, there are only 2 scenarios. If it's bigger than, we have a 4 and 4 is bigger than 3, everything that's after 3, or everything that's bigger than 3 that's after 3 will have 3 as the answer, right? 3 can only be the answer to that question. Let's say the other possibility, which is the number is less than 3. If the number is 1, for example, then in that case, well, 3 can never be the answer, but 5 could also never be the answer. Right? So in that case, it's safe to say that when we see this 3 coming back to here, we can remove the 5. So that's the idea behind the mono stack, and it turns out that the stack is monotonically increasing if you keep this property true, and this is why this is a mono stack. But that's a property that is emergent and not enough, right? So okay, so by that it is not sufficient to solve this problem, because if you implement this problem as I did during the contest, you'll notice that, well, in this case, the 3, 4 will not hit the, let's say we already built this thing out. Well, the 3, 4 will not hit the 5, 4, right? Because they never will catch each other, right? But it will still hit this car when this car combines with this car, right? Because when this car combines with this car at a certain point, well, what happens? What happens is that they become one supercar with a speed of 3. And they combine at a point that is when they converge, which means that, well, the two, well, in this case, let's say the speed is much higher, so that there's less confusion, right? Well, whenever this combines with this, well, 3 is going to be the new speed, and wherever they connect, the thing is that this car's speed will never be closer to this car until it hits this car. So that means that the time that this car hits this car will be the delta between 6 and 3, right? So it doesn't matter when they collide, this car collides with this one. So in a way, you could also pop this off the stack. Okay, so that's part 1. So the answer is that if you do it this way, to get the answer for this particular input, actually, you would actually get, and we could do the math together, but you actually get the answer where this answer is actually 3. Why is this 3? Because the answer assumes that, it takes 3 steps for this car to catch up to this car. It takes 3 seconds, but the answer is actually 2, because actually it takes 2 seconds for this car to match up with this car, right? And what does that mean? And it takes me a little bit of time to kind of figure out what that means, but during the contest, well, the thing is that after 1.5 seconds, this car basically becomes this car, right? So at 1.5 seconds, this car becomes this car. So let's call them, let's say you have a car A, you have car B, and car C, right? So at 1.5 seconds, car B crashes into car C and they merge into one. So that means that it will never take 3 seconds to get from A to B, because B already became another car. The speed already changed after 1.5 seconds. So then now, still as part of the mono stack or stack, and this is why I don't like mono stacks, because it kind of confuses you to kind of be locked in one solution. But it really is just a stack, right? Well, the question is, at 1.5 seconds, this can no longer be the answer, right? So then now we know that from this car to this car takes 3 seconds. That means that we can pop this off. And then now we ask ourselves, then now we pop this off, and then we ask ourselves, okay, that means that we have to do better than 3 seconds, right? Because 1.5 seconds, there's an event. So then we look at their previous car that they crash into, which is their minimum, which is why we pop. And from here, 3.4 to 9.1 is actually 2 seconds, and you could do the math. And that basically gives us out the answer. It's basically, that's why I don't like the term monostack, because in a way it's a monostack, but in a better way, it's just a stack implementation where you're trying to keep an invariant. And the invariant in this case is, there are 2 things. Keep asking, for each car, what is the car I'm going to collide with, right? So that's not the invariant, that's the question. But that's the question that you need to ask yourself. And the invariant there are 2 observations. One is we only crash with cars that came earlier, or that is slower. Sorry, that is slower. And then 2 is how do you say this? As you scan from right to, or as you pop things off the stack, it's when it is at the optimal time to crash the car. Because basically, going back to what we did here, if it took 3 seconds to crash from this to this, but this car is no longer the car at 1.5 seconds, so you have to look at the car it becomes at 1.5 seconds, because it took 3 seconds, right? So basically, the invariant is just, keep true that the top of the stack is the best answer for this current car. If not, we pop, or if not, I guess if not, you just keep doing it. Pop until this is true. And that's basically what my code looks at. And I could actually, I wrote this during the contest, so it's a little bit awkward, but you can actually optimize this a little bit by so how would I optimize this or like in terms of writing this, and then I'll explain in a little bit, is I actually would do something like, I'll just move this if statement here because it's the same. If this is true, we select.pop, and then we continue. So we can move this here, and then we could just move this to afterwards. And note that this break will never happen. But basically, this is my code. So the stack contains 3 things. We have what I have. I have the x, the speed, and then the time. The time of collusion, right? So basically, that's basically what I did. For each top of the stack, we check. If the speed is slower, then we automatically, if the speed is slower, there's no way to catch up to this car, right? So if there's no way to catch up to this car, then we have to try to, unless this car crashes to an earlier car, right? And so therefore, it can no longer be the answer for us, and also cannot be the answer for future cars as well, as we talked about this. And just to be clear, our cars are processed from the right to left, so that we can kind of keep this invariant. And then here this is just a simple formula of the actually, wow, my variable names are terrible. So this is actually dx, and this is v, right, or dv. So this is dx dv, and this is basically the last collusion time, and this is the current collusion time, and this is dx dv. I don't know why I chose the names, but it was terrible. But yeah, but yeah, and then here, as we said, if the current crash time is later than the car, like, how do I say this? If the car we're crashing into already crashed into another car before this, then it can no longer ever be the answer, right? And the reason is because later cars can only crash to it earlier, so then that you're gated that way, right? So then we pop the stack so that the while stack loop goes again. So then we basically do the same thing, right? Otherwise, if it's good, if this is a good answer, then we put it to the answer array, which we also reverse later on, and then we mark the current speed x, the current distance, the current speed, and then the current time that we're going to crash, and then that's pretty much it. And at the very end, I mean, this is at infinite time, because that's, so that this thing will never be true, but it also, because there's no cause for it to crash into that, so that's basically the time that it would go into, and then we just enter append -1 and the x and the speed of the current car that we're crashing into, and that's pretty much it for the analysis. Let me make this slightly smaller so you could screenshot this if you like. Well, with just the quote, and I'm gonna go over the complexity, which should be straightforward to see, which is that the space complexity are more easier. It's linear because we have a stack, and then for the time complexity, well, each car can only be in the stack once, because it either gets pushed, well, it will get pushed once, or, well, maybe it doesn't have to be. But so each item will get pushed once and then pop once at most. So that means that it's going to be constant number of operations per item, and because they're O of n items, so O of n total time. And that's all I have. Linear time, linear space. Let me know what you think about this problem. Hit the like button, and actually, I don't know why, but when I was solving this during the contest, I actually explained a lot of stuff, and it slowed me down. So I don't know why I was doing it, but you could watch that next and let me know what you think. Ta-da! Okay, so I have a hard Q4, so maybe I could catch up some points here. I have 2 WAs. Yeah, this is not looking good for me, but 583rd of 2 wrong answers. That was like this, and I got it like 20 minutes ago, but I just kind of was silly about it. Okay, the end cause. Okay, so speed I. For this one, I want to see how many wrong answers people get, and it seems like even smart people are getting wrong. Oh, but I also got in like 10 minutes, so I have some chance of getting it, maybe. Okay, after one soon. Okay. What does this mean? So you have 1, 2. You find out where they intersect, right? What does the next car mean? Once again, it could be any car, right? Okay. Cars in the form 3. Oh. I wish I got Q3 faster, because now I feel like I'm gonna eat it on this one, because this one's a hard problem. And I should have gotten it. I got it really quickly. It's just I had a typo and then I misunderstood what they meant. I mean, this is. I've car collided with the next car. I feel like they have to explain this a little more, but maybe not. Okay, and then they never collide. Okay, maybe not. I think this explanation is good, though. I don't know why they put explanation in like this. I have to scroll all the way to the right to read it, but that's fine. So it's just about this matching this, right? So you have these events. It's just a sorting thing, and then yeah. Okay, what does that mean? So no matter when, you know that when this one and this one will collide, because it cannot skip ahead. So it's just about timing, and then the slowest car in this free. That's the difference. Is that if this collide, but we can just do the events for that way. How can we update it though? I mean, this is just a heap type problem, but we have to figure out how to do it in a smart way so that when they collide together, because I think this one, like maybe this one could catch up to this one, but because they collided, well, not this case, but is that true? Well, the slowest car will always be the one to the right most, because so the invariant is that when the slowest car, you cannot, if you didn't catch up then by itself, it cannot catch up anyway, right? Like just because another car collided and this would never catch up. Okay, so this is just events, and this is just, is it just adjacent? Like, is there any way to overtake a number? I mean, I think I have to use a heap anyway, but this is doable. I just have to figure out the clean way of doing it, which is because the key thing is you could have something. I think the biggest issue is that you have something like, I don't know the numbers, but something like this, maybe really fast. But if this is next to each other, then you know, so this may get there here really fast, but what am I trying to say? Oh no, I think the other way. I could have something like this. No, then this would always go first, right? You have something like this, then either this hits this or this. Yeah, I'm trying to find a counterexample for why what I'm thinking is wrong, but maybe I'm overcomplicating things. Because people got it really fast. Yeah, well, maybe not 38 minutes. Maybe there's some weirdness here as well. I don't have a counterexample though. But if it was that easy, just math, then it shouldn't be that hard. But I am going to try to, maybe I have to get the wrong answer to find out. What maybe called doesn't, I don't get it, so okay, fine. I'm just going to do it the dumb way, and if I'm wrong, then I'm wrong. Okay, fine. I don't know why I did it this way. That's the space. Oh my god. Oh wait, what? How did this ever catch us up to this? Oh, because after this connects to, or this will never catch up until this hits this, and then now this hits that. So then now the question is, so the n square question is this catching that, right? And then the answer is, for all the numbers to the right, what is the next number that is slower than this so that you can catch up? Okay, so I can do that. Actually that's a different problem, but okay, that's actually cute. I like this one, and I can figure it out, which is why I like it. No, but okay, let me think about how I do it. So going backwards, so this is like a mono queue thing, but I'm going to do it with a heap for sure, probably. So you want to get the next, so what am I asking? So I want to get the, so if this is a 4, I want to get the next number that's strictly less than this. And yeah, and for the 4, the 2, okay. Okay, this is a good problem. I could solve it. Okay. Maybe I should just do something like this actually. For, what's it? Okay, and then I have a stack as usual. Okay. Yeah, okay. Otherwise, we look at the next number that's smaller than this. So, okay, while stack is greater than 0 and stack of -1 speed. So let's go that is greater than or equal to speed, then stack dot pop. Otherwise, and then if length of stack, I guess I didn't need to do this, but then now I have to put stack dot append x speed. Okay, fine. I think I have to do it anyway, but I just don't do that. Answer. Okay. Oh no, I have to do the answer. So otherwise we append. Okay. Delta is equal to stack of -1 of 0 x minus that dx is equal to speed, our current speed minus stack of -1 by definition, and then we subtract dx over the delta, or the other way. Okay, am I done? Wish me luck. Nope, everything is way negative. Why is that? Oh, I don't. No, I pushed afterwards. X speed stack. So I still have the 7 too. Oh, I have to reverse this, but that's fine. But that's still the wrong answer. It's just, right? Yeah, a lot of -1s. But okay. Am I just missing the math wrong? Because I think I got it right. Because speed is the delta speed, and oh yeah, this is, and it's just a little bit confusing. That's all. Okay. That looks good, maybe. Oh no, I got a wrong answer here. It's so hard I don't know why they just don't show us the expected answer, because it's just hard to read. But when did they collide? That's the problem. So we have to do the math there, because 3 catches up to here at second 3, but how do I do the math here? I have to combine the numbers in a good way. I'm glad that discarded, because I would have gotten the wrong answer. So because it takes from 3 to 6 3 seconds, but it's 2 seconds because why is that 2 seconds? So this takes 1 second to collide. Where do you collide? Why not at 6? So after 1 second, we collide. And this is at 4. No, okay, that's why? I'm close, but I have to figure out how they combine. So 3 4 5 4 6 3. Okay, so after 1 second, this would catch up. At this is 9, this is 9, this is 7. So this collides at 9, and this is at 7 after 1 second, and then after the second, I mean, this still moves at 3, right? And this is moving at 4, so this is 11, this is 12. So why does... Am I misunderstanding something? Why is this 2 seconds? Oh, because this may collide with this one. Because at 1.5 seconds, okay. Yeah, I got that part right. So I did not consider it so far, but okay. So at 9.1, at 1.5 seconds, this actually becomes 1. So I have to figure out how to do that. Oh man, that's actually harder than I thought it would be, because I thought I was almost done. Because now we have to care about when does that timing work, right? So when do they collide? This collides at 1 second, so that's fine. But now, no, this collides on this with 3 seconds. But I just have to figure out how to do the math in a good way. So it's not just the next one, though this will collide with this one, but it will collide with this one after. So this is the edge case that I was thinking about, or trying to think about earlier. So this collides with this one, and then this one. That means that at 1.5 seconds, how do I do the math on this? Dun dun dun. So the critical point is at 1.5 seconds, and we do the math is 2. So do we need to store the speed in which they collide? Or the last place where they collide? Because then now we have to care about this, except for we'll never catch up to it, so we don't have to. But we have to worry about this one and this one now, because from 3 we collide with 9. What is 3 connect the line? That's 2, because my math is terrible, so I have to do it. So 10, 7, and then at 2 seconds is 10, 11? Oh, no. This is 11, 11. Okay, so that's why. Okay. But then I have to do everything on this monotonic stack, but that's still going to be n squared in the worst case, so I have to do something better. Okay, I mean, I think that now I just have to look at the events and then process them, and then reprocess them. That is a mess. How many people have gotten it so far? And my penalties are going to be off the roof. Because naively, this would be n squared. How do I know this versus this, right? So I could use some kind of delta array, the suffix sum, do the math that way, maybe, but I think that's okay. I think we could push the answer on the stack and then figure it out. Because if this is bigger than that, then we pop as well. Because that means something earlier happened. Okay, I think I got it. That time you went 0. Okay, and then now we can catch up to everything in between, but then we do this thing again. That is a cool problem if this is correct, but okay. And then the last one is timestamp. So stack -1, 2 time. This is the last time. So that means that this event had happened. So then, okay. is greater than last time. That's good. That means that otherwise we want to pop because, oh wait, no, do you? The last time event, that means that something else has happened, so that actually this pops. And then also that means that this is some infinity value actually for that. So then otherwise we pop, so that we always collide on the last one. Otherwise we pop. Divided by 0. What's tx? Why is tx 0? How is this happening? Oh, I have to do this pops, otherwise break. And also answer. Okay. Enough to YOLO. Let's go. Big money, let's go. Yes. Okay, that was a hard problem, not gonna lie. Hey, yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Take care of yourself, take care of others, love you, everything. And yeah, to good mental health, and I'll see you next problem. Bye-bye.